Hey everybody, welcome back to part 2 of graphing polynomials. We're going to start off by listing a couple of things that are going to be really helpful in order to have you guys graph these polynomials. I've listed them here. I would definitely write these down so you know what things you need to find before you start graphing. The first thing is to be able to identify the end behavior, which we did previously in the last video. So if you didn't have those rules written down, I would definitely go back and re-watch that video, get those written down in your notes. The second is the y-intercept, which we should at this point know is just found by plugging in x equals 0. The third thing are the zeros or the x-intercepts of your graph, and those are going to be found by factoring the polynomial if it's not already factored. So I'm going to show you 3 different examples today where you are going to be able to factor them or they're already factored, and then I'm going to show you one example where they cannot be factored. So sometimes you're not going to be able to use the zeros, but if you can, obviously you want to use them because it's going to make it a lot quicker. And then the last thing is the multiplicity of those zeros, which we're about to talk about. So, multiplicity is a new topic. Multiplicity is just the degree of the zeros when you have it in factored form. So multiplicity only applies if you can factor the polynomial. And so that's why I said if you can factor it, you always want to try to do that because it's going to save you a lot of time when you actually have to graph your equations. So here I have a random example of an equation, just a random polynomial, and we're going to work on practicing finding the multiplicity. So when you have a polynomial, you always want to get it in its factored form. In this case, it's already factored for you. And then you're going to go ahead and find your zeros. So remember, to find our zeros, once it's factored, we just have to set each thing equal to 0 itself. So I'm going to set x plus 4 equal to 0. I'm going to set x minus 1 equal to 0. And then I'm going to set x minus 2 equal to 0. And then all I have to do is solve for x on each of these. So when I subtract 4, I get x equals negative 4. When I add 1 over here, I get x equals positive 1. And then add 2, which gets me x equals positive 2. So I've just found my 3 x-intercepts, my 3 zeros. And then to find the multiplicity, I just have to look at their degree. So if I go back to my factored equation, when it's negative 4, my degree was a 2. So this gives me a multiplicity of 2. And then x minus 1 was to the first power. Even though it's not written, we understand that it's a 1. So this would be a multiplicity of 1. And then my last one for x equals 2, if I look back at that equation, the degree is 2. So this would also be a multiplicity of 2. And you can have a multiplicity of pretty much any number. It could be 1, 2, 3, 4, 5, or higher. What you're going to see mostly in this section, in this chapter, is going to be multiplicities of 1, 2, and 3. You might see occasionally a 4 or 5, but typically that's about as high as we'll go. So there are basically 2 rules you want to write down, and I put these in orange here. The first is that when the multiplicity is 1, or it's odd, because remember we said sometimes we're going to see 3s or 5s, the graph just goes through the 0. And I'll explain what that means when we actually get to the examples, but you want to write that down. Okay, and when the multiplicity is 2, or it's even, so 2 or a 4 or a 6, then the graph is going to bounce at that 0. So it's going to hit your 0 and then go back the way it came. All right, so either you have 2 options, going through your 0 or bouncing at the 0. So let's just jump into an example and then we will go from there. So the first example here, it says graph the equation negative 2x times x minus 3 cubed times x plus 5 squared. So remember, the first thing we want to look for is our end behavior. This is something you can find in any polynomial. So when it's factored, you have to think about what the degree would be when it's FOILed out in its standard form. In order to figure out the degree in its standard form, you do not have to multiply everything out. So instead, we just have to count up all our x's. So if you look here, we have an x to the first. We technically have an x minus 3 to the third. So we have 1x, we have 3 x's, that's 4. And then we have an x plus 5 to the second, so that's another 2. So that means that our degree is going to be a 6, which is even. So we had 1, 3, and 2, and we just added those all up. Now, if it's already in its standard form, you don't have to count. You just have to look at the highest exponent. But when it's factored, you have to count up all the x's. Okay, so we know the degree is even, and then the leading coefficient You can look at that front number to help you tell if it's going to be positive or negative. In this case, with all of these multiplied out, it's going to end up being a negative. So we have an even degree with a negative coefficient. That's going to be two end behaviors that both point down. Okay, and remember, even, they go the same direction, odd, they go opposite directions. So now we need to find our y-intercept. And remember, the y-intercept we just find by plugging in x equals 0. So when I plug in 0 into my equation, I get negative 2 times 0 minus 3 cubed times 0 plus 5 squared. And when I multiply all this out, I get 0 times everything, which just gets us 0. So my y-intercept is at the ordered pair 0, 0. And I'm going to go ahead and plot this just so we have it started. So we know we're going to have a point at 0, 0. I'm going to plot that in green. We know our end behavior is going to go down, so hopefully at the end both our sides of our graph are pointing down. And now we need to find the zeros of the graph. So this is already in its factored form, so we just need to set each thing equal to 0 to figure out where it's going to hit the x-axis. So I'm going to set negative 2x equal to 0, x minus 3 equal to 0, and then x plus 5 equal to 0, and I'm going to solve each of those separately. So I'm going to get, for the first one, when I divide by negative 2, I get x equals 0. Here, when I add 3 over, I get x equals positive 3. And then when I subtract 5 over on this one, I get x equals negative 5. And then I just need to write the multiplicities. So I'm going to do that real quick. So remember, multiplicity, we look at the exponents that go with each of them. So for 0, that was from the first part, my multiplicity was 1. So I'm going to write m1. For the x minus 3, my multiplicity was 3. And then for the x plus 5, my multiplicity was 2. And remember, that's going to help us when we're connecting our graph to make sure that we're hitting, or we're having the right behavior at each point. So now I'm going to go ahead and plot my x-intercepts. So remember, we have 3 of them here on the x-axis. So I have something at x equals 0, which we already had a point there, so you can cover it up if you want again, but you don't have to repeat points if it's already there. Then we have a point at x equals 3, and then we have a point at x equals negative 5. So there's my last point. So once we have our end behavior, y-intercept, and zeros, all we have to do is connect our points that we're given. If you want, when you graph these, it never hurts to make a table and plot some extra points to make your graph more accurate. But mainly I'm looking for a rough sketch of your polynomials with these 3 things as the priority. So we know our end behavior goes down both sides. So I'm going to go ahead and from my furthest points, I'm going to go down this direction, down that direction. So that takes care of our endpoints. And then we have to look at our multiplicity at each 0. So remember, at negative 5, so this first point right here, we said the multiplicity was at 2. So that means that when it's an even multiplicity, it bounces. So what that tells us is that our graph is going to come up, hit negative 5 on the x-axis, and then bounce back down. Okay, so this is the example of what I meant when I said a bounce. So it hits your 0 and then it bounces back the same direction. It doesn't go right through it. So then we have our graph going down at this point, but we have to be able to come back up to hit our next 0. Well, our next 0 was at x equals 0 and the multiplicity was 1. Well, at odd exponents, or sorry, odd multiplicities, it went straight through. So I'm going to have to curve my graph back around and come up to hit this next x-intercept at 0. And because it was odd multiplicity, I'm going to go right through it. So just like that. Okay, and then remember, the whole goal is to end up going back downward because that was what our end behavior told us to do. So I'm going to have to bring my graph back up and then curve it. So we have another turning point here and bring it back down through my last x-intercept, my last 0 at x equals 3. And it also had a multiplicity of 3, so it's an odd multiplicity, so it's going to go through it as well. And actually, when you get into higher odds, they kind of level out just a little bit and then come back down. So it's like a little flattening hits that point and then goes through it. So notice that through my odd ones, I actually go right through the points, whereas in my even multiplicity, I bounce. Okay, and then this would be your graph. Now, where I would suggest making some extra points to plot would be between your zeros. Now this one I know for a fact between the zeros goes really low and really high and you wouldn't want to graph them. So this is just a rough sketch, but sometimes you might get some nice numbers to plot in between, and that's going to help make your graph a little bit more accurate. So the more points you have to plot, the more accurate your graph's going to be in the end. Right? And this would be the final graph of this particular polynomial. So let's look at example 3. So this one, it says graph this equation here. Now notice this is not in factored form. So right away, end behavior is a little bit easier to find. So we want to look at the degree, and the degree is the highest exponent. Remember, we don't have to count when it's not factored. So the degree is 4, so it's even. And then our leading coefficient is the number in front, which is a 1, and it's positive. So here we have a polynomial whose end behavior is going to go up in both directions. Then we need to find the y-intercept, so we'll do that next. So remember, we plug in zeros for all of these, and if I plug in 0 here, here, and here, everything's just going to become a 0. So there's some quick mental math. So my y-intercept is at 0, 0. And then I want to find my x-intercepts. So this is where, if you can factor, you want to, and if you can't, you just have to leave it and make a table. But we notice that all 3 of these things have something in common. So what can I take out of all of them? Well, I can take out an x squared. So when I take out an x squared out of my equation, I'm going to have an x squared out in front, and then what am I going to be left over with? Well, when I take 2 x's out, I'm going to have an x squared left over. Then here I take 2 x's out, I'm going to be left with a minus 4x. And then in the last part I take 2 x's out and I'm left with a plus 3. Now I look at this and think, can I factor this any further? Well, we know our factors of 3 are 1 and 3, and they can get us a 4. So I'm going to go ahead and separate it into its 2 parentheses. So I'd have x and x, and a 3 and a 1. And both my signs will have to be negatives. So this is a really good practice for factoring polynomials. So this is its factored form. So now I have to go ahead and set each thing equal to 0. So I'm going to set the first thing equal to 0. So x squared equals 0. And I'm going to set the next thing equal to 0. So x minus 3 equals 0. And I'm going to set the last factor equal to 0. And then I'm going to solve each of these. Well, the first one, if I take the square root of both sides, I'm just going to get x equals 0. And the next one, if I add 3, I'm going to get x equals 3. And then the last one, if I add 1, I get x equals 1. And remember, we have to look at our multiplicity. So the multiplicity of the first one, the power was a 2, so it's a multiplicity of 2. And both of these were powers of 1, so they have multiplicities of 1. And I just write it underneath just so you don't forget it. But obviously, there's no special way to write that. And now we can go ahead and start to graph. So I'm going to get my little graph here. And you'll want graph paper for this. And what you label it by and what you count by is going to change for every problem. So keep that in mind. So I'm going to have my y-intercept at 0, 0. So plot that point. That's also one of my x-intercepts, so I don't have to do it again. It's already there, so I've taken care of that. Okay, and then I have a point at x equals 3. So let me plot that in red. And then I have a point at x equals 1, so there's another one. So there's my 3 zeros and my y-intercept. And remember, we know the end behavior goes up in both directions. So on this side, it's going to go up, and on this side, it's going to go up. And then you just have to pay attention to your multiplicity. So remember, the multiplicity at 0 was a 2, so it's going to bounce. So I'm going to take my left side, hit the 0, and then bounce back up. Then I have to come back around. I have to turn it because at x equals 1, it's going to go through. So I'm just making myself little notes. So I turn my graph, hit x equals 1, and go through it. And then remember, at x equals 3, it has to go through as well. So I'm going to have to turn my graph and come back through at x equals 3. And then it goes up the rest of the way. So notice that my or my multiplicity helps me fill in to fit my end behavior as well. And if you wanted, like I said, you can always make a table real quick of x's and y's, and maybe you plug in x equals 1/2 to figure out how high up this goes. Or maybe you plug in x equals 2 into your equation and figure out how low this goes. And it will just make your graph that much better when you are practicing. All right, but this is the general form of this particular polynomial. So this example is going to be the last one I go through today, and then we'll practice more in class, but this is an example of a polynomial where maybe factoring is not going to be so easy. You can always try synthetic division and see if anything works, but if you don't find anything nice and you can't factor it very easily, then my suggestion is to still start with the end behavior like we've been doing. So I'm going to go ahead and write this down. So the end behavior we can find obviously by the degree. So the degree in this case is 5, so it's going to be odd. And then the leading coefficient is a negative, so we're going to have on the left it's going to go up, and on the right it's going to go down. Hopefully those rules you're catching on to. And then I can still find the y-intercept just like we did on the other examples. So when I plug in 0 to all of my x's, everything cancels except for the last number at 1. So my y-intercept is going to be 0, 1. And if you have questions over that, just make sure you ask me. And then because we can't find the zeros very easily, so it's not factorable or not factorable very easily, then I wouldn't even try to do that. So you're not even going to be able to plot values on the x-axis, or you're not going to be able to use the multiplicity either. So rather than trying to figure out what those numbers are, especially if they're decimals, this is where I would say instead you can use a table. So I would just go ahead and make an XY table and pick some numbers to plug in. Now, one suggestion I'm going to make is to always pick some positives and some negatives, but you're going to have to be flexible a little bit because every graph is going to be completely different, so you can't always pick -2, -1, 0, 1, and 2. Sometimes you're going to have to pick fractions, sometimes you're going to have to pick big numbers, sometimes it's going to have to be small numbers, and it's kind of just a little bit of a guessing game, and you just have to adjust as you go. Just have some patience, have your calculator ready. Maybe in this one I suggest trying something like -2, maybe -1/2. You already know what it is at 0, so you don't need that, but maybe you try plugging in +1/2, maybe +1. If you want to try something bigger, maybe try +4. But what you're going to remember is that these graphs go up and down drastically, so if you plug in too big of a number, you might get something really high to plot, and that may not make it very easy. So plug in these numbers very quickly into your calculator. You want to do that, make your table, and then you can go ahead and connect your points. So the more points you have, the better, but don't be afraid to plug in fractions or decimals or something like that, because it's going to make your graph more accurate the more points you have. So what I would go ahead and do is try this one on your own, plug these points maybe that I've written down, maybe pick some extra ones that I didn't write down, and then try connecting your graph using your y-intercept and end behavior. And then if you have any questions over it, just make sure you ask me in class. And that's it for today. Thanks for listening.